Hello and welcome. So we have a box with a square base and no top is made from a square piece of cardboard by cutting 7-inch squares from each corner and folding up the sides. The box is to hold 23,548 cubic inches. How big is a piece of cardboard needed? All right, so a couple of things are happening here. We're making a box with a square top, and how that happens is that we have what we were told is a square piece of cardboard, right? And on this, what we're doing is that we are cutting in each side. And we're cutting out the same amount out of all of these, and then that's going to create these kind of fold marks where once we fold it up, that'll create a open box. All right, so here's the base, right, and then the sides that were folded up from before. Okay, so that's currently kind of what the situation is. So let's figure out what we do now. All right, we know that we're cutting 7 inches in, so that means that's 7. But we know that they're 7-inch squares, which says that every one of these is 7. So in relation to my box, what would that be? Well, that would be the height, right? Because if we're cutting 7 in and then we're folding that piece up, that is that edge, right? The height of the actual box itself. Okay, so that's nice. We know that at least. And then it says the box is to hold this number right there. Now, when we're told cubic anything, right, something to that third power, that is a measurement of volume. So that means that my volume equals 23,548. Okay. Now, why that helps us is that we can actually find the volume of this thing, right? The volume of we're going to say rectangle here, or rectangular prism, we could say, is essentially going to be the area of my base, so length times width, but because we know our base is going to be a square, because we started with a square shape, and we're cutting the same amount out of all of the sides, so it must be a square. Okay, so that means I'm going to go length and length, so length squared times my height, which we just happen to know is 7. All right, so length squared times 7 equals 23,548. All right, so that means that length of my box would be that length right there. All right, so we can actually solve this equation right here for what we do need, because I know the volume equals this, but I also know the volume equals that, so they're equal to each other. So 23,548 equals length squared times 7. How do we undo multiplication of 7? Well, that would be division of 7. So I'm going to divide by 7 on both sides. So we get 23,548 divided by 7, which goes in evenly. We get 3,364 equals my length squared. All right, I'll do squares with a square root. So we take the square root of that 3,000 number. So we get square root of 3,364. And fun fact, that's also a perfect square. The length equals 58. Now you might be tempted to put that 58 right here, but it's not. It's not going to be correct. And the reason why is that we wanted to know how big of a piece of cardboard is needed. That cardboard is the thing we're cutting into, as this outer edge here. And our blue L, the thing that we just solved for, is only that piece of the whole thing. Well, it's not hard to find what we need, though, because the remaining edge, we know that, and we know that. That's 7. We know that's 58. We just solved for it, and that's another 7, which means what's the side of the square? Well, that would be 7 plus 58 plus 7. In other words, 72. So my answer is 72 by 72. Because I know this is a square cardboard, which means that all of those would have to be a side length of 72 as well. And there you go. That is how I would solve through this one. Not too bad when we know it's a square. Kind of nice to work with there, but that is as crazy as it gets. Thanks for watching.